listeners, let me tell you about positive environmental science. So the AP Environmental Science exam isn't simply a test of knowledge, it's a test of skills. So these are the science practices. In my classroom, I've seen that some of the biggest stumbling blocks for students are these practices 5 and 6, data analysis and mathematical routines. As a math and physics teacher, I know that the best way to master a skill is to practice that skill, right? So some classic things that a lot of us have tried to give our students more practice with mathematical reasoning skills in APES. Assigning the problems every unit before a calculation-based FRQ, do some similar calculations in class, doing data analysis on all the labs, and then in a last-ditch effort, try to review all the material of math in April and May before the exam. Some problems that I've had doing this, implementing this, and I know these are not just happening at my school, is that students cheat. They look up answers on the internet or copy their friend. Not all students do this, but it is a problem. And there's a lot of reasons for this problem, but one reason that I truly believe is a big part of it is that students see a word problem and they just don't know what to do. So they copy an answer. And then they didn't learn, so they still don't know what to do. And then they're in this vicious cycle. And I was seeing this in my APES classes all the time. Meanwhile, I've been using a website called Positive Physics with my physics classes. It's scaffolded practice with randomized variables. And I thought to myself, something like this would be really amazing for my APES students. So long story short, I learned a little coding and made an environmental science course on here. And I'm going to show you how it works. So there's the environmental science course that you'll click on, and then click on the unit you want to do. I'm going to show you the Unit 5 semester exam review. So looking at the unit analysis problem first. It's a classic math skill. Here's some formulas that you'll see for students to practice, all those different types of problems. This problem says a 21-acre area of old-growth forest is set to be clear-cut, and we want to do a unit conversion into hectares. If a student doesn't know which one to put, they can check their answers, and then if it gets wrong, they get to try again. And then they'll put in the conversion problem from the given units and check their answers again. And there's a Desmos calculator linked in, but they're welcome to use the calculator that they're most comfortable with. They can put in their answer, 8.4. Now the units are hectares. Let's check and see if we got it right. And now that student has built some confidence and practice, they can try harder and harder problems, maybe without the labels, maybe with a graph to interpret, maybe with more steps. And now they've seen that they can do it. So what you'll see on the site, go to the next part. Okay. You'll see lots of practice for each question type. The blue numbers in the words are randomized. They're all variables that will change for each student. You'll see questions that are scrambled. It'll turn green when the student gets it correct. And there's unlimited attempts. So you as the teacher will see a accuracy score and a completion score. And you can choose to evaluate your students on either of those or just the completion score. It's up to you. What this means for you is there's less cheating in your class, less grading for you, and more mastery. This is a quote from one of my students. After using positive environmental science, she said, "I might as well just do it myself because I'm going to have to do it all anyway." And I will add that she really mastered the quantitative skills in the course this year. So I started with the math skills, which is a big part of the course, but I have since added in practice for all of the other skills too. Some text-based skills you'll see throughout all the units include reasoning through environmental problems and solutions, understanding processes through diagrams, and experimental design questions. Let me show you an example of that here. So there's students designing an experiment, a text-based problem. Students will choose which variable is seen here, and these, the blue that you see on the left will be randomized, so students won't just look over and copy each other.